Hi friends, in this video we're gonna see what are stick diagrams and how to do stick diagrams, what are the types of design styles and how to draw them. Now basically for designing any circuit, any IC or circuit, we need to follow this procedure. First we need to have the floor plan. That plan should be of, first we need to get the stick diagram of the plan of the circuit whichever we want to design. Next thing is we need to get the layout. After getting the layout, we need to get the mass for the fabrication of the IC. Okay, so first and most important thing is that we need to get the stick diagram of the layout. Now if you see here, Nmos design style. There are two types of design styles here. One is Nmos style, other one is Cmos style. Okay. Now in this video we are going to see what is Nmos style. Then after that we will consider what is the Pmos style. So here, whenever we consider Nmos, this is the Nmos fit, right? Okay. So here this is a Nmos fit. Whenever there is a Nmos fit, if I am indicating a dot, that means multiplication, then dot indicates the Nmos multiplication. Okay, and plus indicates Nmos addition. Based upon this, we will design the stick diagram of any arbitrary circuit. Okay, so basically, whenever we consider these styles, under Nmos only, we have two types of design styles again. Okay, one is, suppose I'll consider a circuit of NAND gate. Okay, suppose there is a function a dot b bar. Okay, I need to design this Nmos design style for this circuit. Now here what happens is, first thing is that resistive load. Resistive pull-up. Okay, so how this resistive pull-up looks like is, whenever I go for a dot b, I said Nmos multiplication. Okay, for that this means this is in Nmos should be in series, for addition it should be in parallel. Okay, now I have my Nmos to be in series. I have given the inputs A and B. Okay, now in order to get my output back, I am using the resistive load here R, where this is VDD, that is F equal to A dot B bar. Okay, this is the ground. Okay, so these are the two transistors, Q1 and Q2. Okay, so using two Nmos, here whenever I am designing any circuit in Nmos style, remember that how many number of variables are there, those many number of transistors I need. Okay, so I have two variables A and B, so I need two transistors in series to get the A dot B, where this resistive load, this is acting as a pull-up network, whereas this is acting as a pull-down network. Okay, this pull-up network makes the entire product which is getting as a complement here, which gives me the required circuitry, required output. Okay, now we will check the operation of this. Okay, how is it performing the inverting operation? Now I will consider A, B and the output F. A, B and output F. Suppose I have given my 0, 0 as output. I have given 0, 0 as input to the transistors. So as it is an Nmos, first thing we need to remember is, whenever we are talking about Nmos, it has whenever it is 0 input, Nmos is off. Okay, whereas whenever we are considering the PMOS, then 0 is on. Okay, this is the PMOS, this is the Nmos. For Nmos, 0 input means the transistor is off. For PMOS, 0 input is transistor is on. Okay, so here when I am giving the output 0 0, input 0 0, then these two transistors are off. So entire VDD which is there, that will be my output. So my output will be VDD, which I indicate as high. Output high. Okay. Similarly, whenever it is 0, whenever this is 1. Now A is 0, this is 1. This will be the open circuit. This is connected to the ground. So there will be no connection here. So entire VDD will be flowing through the circuit. That means this is the output again. Now whenever this is 1, this is 0. This is 1, that means this is on. This acts as a short circuit. Whereas this is off. That means again it's an open circuit. There is no connection between this. So again entire this is the open circuit. That means here it will be the ground. So whatever VDD is there, that will be flowing through output. Now the last case, 1 and 1. Now here what happens is, when it is 1 and 1, I have a resistor and this is short circuit, and again this is short circuit, this is ground. This is the output F. So whatever current is flowing, it will be flowing through the ground. Okay, this makes my output to be 0. This is less compared to this. Okay, so output will be approximately equal to 0. Okay, so my NAND gate operation is as follows. Okay, if you know the table of the NAND gate, it will be exactly the same, because it is a complement of AND. 0 0, AND will be 0, but it is a complement, it should be 1. For everything it is 0 except 1 and 1 for AND gate, but the complement we got is NAND gate. Okay, so this is using resistive pull up. Okay, for the same case, if I use depletion Nmos pull up. Okay, this is second case. That means here wherever I have resistor, I will remove this and I will place a depletion Nmos. Okay. Is the depletion Nmos here. So again output will be the same, but change in the style of design. Okay. Here also the same thing for us. What is the depletion Nmos? What is the difference between enhancement MOSFET and depletion MOSFET? It is that here already channel is formed. There we need to give some voltage for the enhancement MOSFET to form a channel. Whereas here depletion MOSFET is always on. Okay, and it is always having the channel ready for the operation. Now this is acting as a pull up, whereas this is acting as a pull down network. Okay. Now whenever we design this NMOS design style, mostly we follow this part, what is called depletion NMOS, pull up and pull down as NMOS transistors. Why? Because if you consider the resistor, the size of the resistor is more than compared to the transistor. So for the fabrication it will be a problem. The size will be the factor where we need to get a trade off. Instead of that, we will go for the NMOS depletion. Okay. Now, I hope I am clear with what all the series and parallel connections. Now, we will consider an example here. Okay. For stick diagram. For the same case, stick diagram. Okay. Suppose I'll say it as example 1. F equal to A dot B. First you get the circuit diagram, that means the transistor diagram, then we need to draw the stick diagram for that. Okay, so Nmos transistor. This is Nmos transistor, and I need both to be in series. So I have two transistors in series with inputs A and B. This is the ground. This is my output. A dot B bar. This is VDD. Okay. Now for this I need to draw the stick diagram. Okay. How does this stick diagram looks? First, this stick diagram have the same parts which we have in the same component which we have in the circuit diagram, but we will denote it using the sticks. This is called stick diagram, and these stick diagrams and designs, those are mainly based on the rules of lambda and nu. Okay, we have two types of rules, design rules, lambda based design rules and nu based design rules. Okay, based on that we design. Now here I'll just draw the stick diagram of this. Later on we will see how to design design the components of each and every circuit. Okay, now here first I have VDD. Next I have to draw the ground, because these two are the bases for any transistor. Okay, so here I have drawn VDD and ground. Okay, now after that I have a transistor here, Nmos transistor. This is a metal contact. I'll take a metal contact here directly. Okay, I'm using the transistor. So this is how I denote Nmos transistor. Okay, now after that I have a two Nmos transistors here. Okay, so I'll denote one, both the transistors with a cross. This is the gate, source, drain. Gate, drain, source. Okay, both are in series. This is the ground. Okay, here I need to connect this part, this will be the output. A dot B. Now okay, this is the showing, this is the Nmos depletion mode. Okay, now this gate part is denoted by red color and this part is green color. Okay, similarly this part is red color, this part is red color. Okay, and this part, this is A, this is B. Okay, this is the stick diagram of the AND gate F equal to NAND gate F equal to A dot B bar. Okay, that's all for this video. Thank you.